Hi everyone. Firstly, thank you for selecting my talk. My name is Aashima and I am really excited to be here today. So today I want to talk about something which doesn't get enough attention. React beyond smartphones, basically for TV and auto applications. So when most of us think React Native, we immediately picture our mobile apps, right? But here's the thing. Android today is everywhere. It's powering our smart TVs, it's running in our cars, and so much more. So this entire session is dedicated to talking about those React Native skills that we have already learned and how we can extend them to develop applications for TV and auto. All while making sure we are working with and not against the unique demands of the new environment that we'll be talking about. Let's map out exactly what we'll be covering today. We will be kicking things off with while we talk about how Android is used into smartphones, and then we'll dive deep into the unique challenges we face when building for TV and auto platforms. From there, we'll explore why React Native might just be a solution for these, and we'll see exactly how everything works behind the scene. Let's completely flip how we think. We are not talking about phones anymore now. Android has evolved into this incredible versatile platform that's literally around everywhere. Think about this for a moment. In the past, if you want to build something for Android, let's say for Android TV, you had to deep dive into Java or Kotlin. For Android Auto, well, that means mastering some car app library. Mobile apps, you will have to deep dive into React Native for that. But here's the kicker. That's 3 complete separate code bases, and with 3 totally different skill set of people who will be building that, and 3 times the maintenance cost as well. So where do we stand today? For TVs, Android TV is powering in millions of streaming devices right now. And users, they are not settling for basic interfaces in today's world. Cars is being exciting right now. Great cars are having wider displays, and Android Auto isn't just some Google car concept anymore. We are talking about BMW, Honda, and dozens of manufacturers which have embraced the auto platform. It's not divided till cars, mobiles, or the TVs. There are wearables and tablets as well now, which is growing in this ecosystem. But here's where it gets difficult. Every single platform has its own unique UI, patterns, and constraints. That's just the reality. But when you look under the hood, the core business logic is virtually identical. The user authentication works in the same way. Data fetching follows the same pattern. State management applies the same principle. So the question is why we are running all the 3 in the same, why we are not running all the 3 code bases under a single one. Before we look further, let's just understand what makes all the platforms so special. We are not talking about bigger or smaller screens, but the way of interaction with these 3 screens are completely different. Let's start with TV. It's trickier than what we think. So in television, there is basically input methods and there is no touch screen. The user is sitting on a couch and is navigating with the D-pad and a remote. There is a 10-foot rule which we apply when we are developing for TV. People sit way back from TVs. That means bigger text, higher contrast, chunkier buttons, and basically what looks good on your phone will be invisible from the couch. There's also high resolution 4K performance tuning in TV. The picture should be crisp, but many of these devices are running surprisingly on limited RAM and processing power. As well, Google's also got an opinion. The lean-back library isn't just a suggestion, it's what users expect to see. Now, if we talk about automotive or cars, this is where things get serious. Safety isn't optional. Driver distraction law exists for a reason. The app needs to be demand as little visual attention as humanly possible. Touch is basically off limit when someone's driving. Auto apps live in a predefined templates, so there is no room for custom layout. Cars also drive through dead zones. The app should better work in an offline manner as well. As well, every screen size is different, the processing power is different, and the sensor is different. Now, why this matter? These aren't just interesting facts, but they'll fundamentally change how we will be building applications for all of these. So, if we picture this for a moment, on the left, we have the TV world where someone is sitting on a couch with the remote in their hand and is in a relaxed state. On the right, there is the car environment. Driver's eyes on the road and hands on the wheel. Safety is everything here. Now compare that to the mobile development. We are used to touch screens, flipping between portrait and landscape, and having someone's complete undivided attention. TV and auto, they throw up single one of these assumptions out of the window. But here's the thing. The constraints aren't roadblocks. They are just like gold mines over here. When we design with these limitations, we end up building a more focused and more intentional application that truly serve the purpose. So traditionally, supporting multiple Android platforms means juggling separate teams with widely different skill set. The old way looks like we would require a mobile team, a TV team, and an auto team with the folks who are specialized in each category. Here's what goes wrong. 3 different teams requires 3 set of code bases and typical difficulties. Feature launch at different times basically drift apart the business logic as well. Here we are not trying to push some pure JavaScript solution, but we are just looking into a smart bridging capability where we can just bridge business logic and state management while native module handle the platform specific UI and hardware stuff. Let's break down how this multi-platform blend actually happens. So picture your React Native. Right in the middle, we have all the shared business logic, state management, and common components that are live. So if you talk about business logic, all our authentication, API calls, data processing, we write it here and use everywhere. All the state management and all the common components exist in the middle. Then you have got your TV platform-specific layer where TV gets the focus management, lean back integration, and 4K optimization. Auto gets the essential voice commands, template handling, and rock-solid offline mode. Plus, share bridges helps in analytics crashing report and stuff every platform require. Think about a very simple music streaming app. Your playlist logic, user preference, streaming engineer identical, it's everywhere. The only thing that change how it looks is the grid for TVs and the voice list for autos and touch-friendly interfaces for mobile. Now let's look under the hood at the technical architecture and how we are making it all work. So this isn't complex, but it's a smart system of how bridge and adapters are working together. So firstly, we have our JS thread, which executes all the business logic and is JavaScript driven. Then the bridge, think it as of a translator. It is where we manage all the messages, packages, and we just send them across on the other side. Then we have our native modules. This is the platform-specific this is where all the platform-specific heavy lifting happens. TV focus management, auto template rendering, all the specialized stuff happen here. Finally, our platform views, where we render our UI. And here's the key insight. The bridge is actually not slowing down what we are building, but if we use it right, we can constantly look forward to push a better advanced app altogether for all three platforms. Let's address the key question: why native for platforms that traditionally require native development? So we are talking about one agenda over here, which is write once and adapt everywhere. More practical and more powerful. Not only leverage the React ecosystem, but with the existing libraries, development tools, and team knowledge, it also helps in development velocity. Hot reload, shared testing, and unified CI/CD. It also helps in strategic advantages. We can do very quick market expansion for TV and automotive markets. The resource is very efficient. Smaller team supports more platform effectively, and we can innovate very fastly if we work here. Now let's talk about how we can bridge for TV. So Android TV development traditionally require deep expertise in lean-back libraries, Google specialized framework for TV interfaces. Let's examine how we can bridge the technical gap. So the bridge journey begins in a way. So if you look into the diagram, it illustrates the transformation path from a standard mobile React Native application to a fully featured TV application through strategic native bridging. We develop native Android modules that expose lean-back UI and all the components directly to the JavaScript. JavaScript controls the data flow, state management, and core business logic. Here's the most complex challenge: managing the focus state across all the UI elements. Our bridge translates React component hierarchies into lean-back focus management frameworks. If we talk about an example implementation, consider this flow. When the user presses right arrow on the remote, native focus system calculates the next component target and updates the JavaScript state accordingly, which triggers and re-render with a proper visual highlight. And similarly, we have a bridge for Auto. So Android Auto presents even stricter constraints than TV. Google enforces a specific template for safety compliance, arbitrary UI, layouts are not simple and are not permitted. We have template-based architecture. Our bridge transforms React Native components into auto-approved templates. Consider this as a transition layer. JavaScript defines the experience for the user, while the native code renders the safety validity templates. Here, the bridge components consist of the native modules, messaging, and media. We focus on a safety-first design where every user can interact with Google's safety validation system. Unlike TV, we really focus on voice integration. Auto primarily depends upon the voice integration. Now let's trace the complete user interaction flow to demonstrate how all architectural components work together in practice. Step-by-step breakdown, we first will look into business logic and UI definition. So React Native, JavaScript defines data presentation requirement and available user interaction patterns. We'll also look into asynchronous communication. So here, the bridge facilitates how the communication happens, and with user interaction, we triggers event flows through JSON messaging protocols. Then we have native module interaction. Platform-specific native code executes the actual UI, and then we have platform UI rendering. Native view display platform appropriately in all the interfaces for each targeted environment. User actions are transmitted back to JavaScript in runtime with the event feedback. So why this basically work? It provides clear separation, performance, and easy maintainability. So here's the quick JavaScript implementation. This code might seem very simple to any React Native developer. The key points are, this is a familiar pattern. The native modules are imported exactly like any other library dependency. We have a clean interface that will help to manage any complexity of the cross-platform media playback. So if I go into the technical breakdown, native module represents over here, the native module represents a React Native feature which enables JavaScript communication with the native code that's in Java and Kotlin for Android, Swift and Objective-C for iOS. Automedia Mobile is our custom native module, which is created for Android implementation side. The button component uses a standard React Native UI pattern. When the user taps to play the song button, it triggers the play button with the track identifier 1, 2, 3, for example. On the native side, we handle actual platform specific functionality. This example demonstrates bridging the Android Auto's media API. So basically, a Java developers write familiar React code while native developers implement platform-specific optimization, and both teams work within the respective areas of expertise. Mobile applications assume touch input capabilities and user can tap anywhere on the screen, but TV applications are directional with input controls. If I talk about D-pad navigation, every remote arrow key press must produce predictable logical navigation. Users expect every interactive element using only direction controls. There's also a focus grid concept. So Android TV employs a focus grid system, which is visualizing the pathways that connecting all the interactive elements. The system calculates focus target based on subtle relationships and developer defined hints. So the flow goes like remote input, focus manager, grid of items, and highlighted item. On TV platforms, you don't think about click interactions, you think about focus states. The React Native application must deliver a smooth focus grid that feels natural with remote navigation. If I talk about the key elements over here, has TV preferred focus instructs Android TV which component should receive initial focus and when the screen loads. On focus is a JavaScript callback which triggers when this component receives the focus. Style adaptation is for visual feedback modification based on the current focus state. Border highlighting is a standard TV UI pattern which is focused on how we can display visible border indicators. So basically, it's all different for auto. Fundamentally, it transforms the user interaction patterns with the application. Touch input remains available, but it is actively discouraged. The primary interface are voice commands and steering wheel controls. We work with auto on a safety-first architecture, and voice integration is must over here. Here's our implementation approach for handling voice commands and steering wheel input in our auto application. If we look into the code breakdown over here, auto navigation module provides a bridge interface that connects to the Android Auto API. Command processing is the handle auto command function which receives processed voice commands and button press events. Auto API integration, commands execute through auto safety approved interface implementation. So in the real world, when user says play my road trip playlist, Android Auto Speech Recognition System convert speech to text. Our JavaScript process the user intent, and the playlist lookup operations is performed, and the playback is initiated in the auto media template system. Now I want to walk through a real world example. Basically, how is it running on one app on mobile, auto, and TV. The architecture in action. So basically, this diagram illustrates an app, a very simple example. At center, we maintain shared JavaScript code containing music catalog management, user preferences, and playlist functionality. Here's the critical insight. When users want to create a playlist that logically remains identical across mobile, TV, and automotive platforms, um, the create playlist function helps with all the authentication system and music search algorithm, and all of this is implemented in JavaScript under shared JavaScript code. There is also adaptation strategies. It is critical because for mobile, we want a touch-friendly, scrollable interactions. For TV, we want large grid card layouts, which is navigable with remote controls. And for auto, we want voice control templates. I will now talk about application, which is a very simple example. So if we run the same music app on mobile, so like starting with mobile, the familiar React Native experience, notice the touch-friendly interface over here, the scrollable list, and mobile optimized layouts. The core feature over here would be touchable opacity, flat list and grid layouts, responsive styling. Behind the scenes, we'll also discuss the business logic, handling the playlist management, user preferences, and media streaming is identical to what we'll see on other platforms. Over here, this snippet demonstrates a standard touch-first media list. It's simple, responsive, and efficient. Exactly how you will start your shared JavaScript code. If we talk about the technical breakdown, flat list renders scrollable media item efficiently. Touchable opacity makes each item tappable for the first interaction pattern. View component is wrapped in item content, and text elements display song titles and optional optional metadata, including artist and duration, and the metadata is, and the on-press callback triggers JavaScript function that handles playback operations seamlessly. On this UI, if I tap to add song to the playlist on the plus icon, with mobile interaction, I would see smooth scrolling, touch feedback, and responsive animations. Behind the scene, our JavaScript is calling add to playlist with the song ID and updating the global state. The key mobile features would be touch interaction, vertical scrolling, and rich visual feedback. The shared logic here is every action which I demonstrate, like searching for song, creating the playlist, managing the favorites, this will be identical across all the platforms, only the UI change. Now the same application on Android TV, we will see how the interface adapts for D-pad navigation. But the key difference would be focusable cards. Every item can receive focus and provide clear visual feedbacks. Grid layout, it is optimized for TV, viewing distances and screen sizes. Highlighted state, current selection would be clearly indicated and visually emphasized. And lean back integration, smooth native TV navigation experience throughout. User can navigate through all the content using their remote control or D-pad. The focus system ensures logical, predictable navigation path across all the interface elements. If I talk about the technical implementation, flat list with num columns is set to 3 that creates a grid layout for TV browsing patterns. Pressable support focus and press events on TV platforms. And the has TV preferred focus property ensures the first card receive focus when the screen is loaded. The on-focus callback tracks which card is currently highlighted. Dynamic border color provide visual highlights on the focused item, and the on-press callback trigger action when the user press OK or Enter button. Under the hood, the lean-back API maintains a smooth, predictable navigation. Now let's examine the same app on Android TV. I can access the same road trip mix playlist which I could have created on my mobile. If you will see, the UI is different over here. We have transitioned from the vertical mobile list to a horizontal TV grid. This isn't simple resizing, it's complete interface shift. TV specific adaptations would be a border that shows the current selected state, 10-foot UI rule, which is why there would be large text, cards for living room viewing distances. We have a grid layout to support all the horizontal navigation and smooth animation that feels native to Android TV. So the same playlist data, same business logic, but completely different interaction model. The TV doesn't know that it's running on React Native. It feels like React Native. It feels like a native Android TV application. Finally, Android Auto. If we'll notice here how different the interface will appear. We will use Google safety approved template over here. Since beginning, as we are speaking, we work on the safety first design. Primary, the interaction method is for the driver safety. When the touch is available, the elements are resized for easy selection. And we'll also try to reduce the cognitive load of drivers during this development operation. So if I talk about technical implementation over here, the native modules and the auto media module bridges JavaScript to Android Auto native APIs. The play track function with track ID parameter triggers playback in the driver safe auto template. React Native handles the business logic, including which track to play, and the UI follows safety regulation, which is glanceable, minimal, and usable via voice or steering wheel buttons. This approach will keep the driver's attention on the road while enabling developers to use the shared JavaScript logic. Finally, let's just look into the UI quickly. So this is TuneStream in Android Auto. This is where our architecture really demonstrates its value. The most constrained platform, but still delivering the same core functionality. You will see how the UI is different dramatically. We are no longer dealing with grids or smooth list, and we have live demo actions where we can use voice commands to interact with the application. To complete the circle, the playlist that I created on my mobile, browsed on the TV, is now playing in my car, all from the same React Native code base. The business logic never changed, but each platform provided the optimal user experience for its context. Demo conclusion would be 3 platforms, 3 completely different user experiences, but 1 shared code base. And we are handling all business logic under the single hood. That's the power of strategic React Native architecture. Write once, adapt everywhere. Thank you.